everyone. I'm going to talk about how we started a dedicated performance team at Pinterest when we didn't have one before, and how we started trying to get performance to be a priority at Pinterest. So I'm here from San Francisco. It's currently 2 in the morning there, but it's all good. Let's start. So right now, it's giving the talk today is just me, but this is the performance team at Pinterest. I had to include it because I love my team. We are a small team, as you can see, just 3 of us working on web performance. So what am I going to talk about today? So I'm going to talk about what got us started on starting this first dedicated performance team. And then I'm going to talk about some of the challenges we are facing and that we've faced and how we've tried to solve these problems that we have with performance at Pinterest. So this is everything from creating the overall strategy for performance, not just the day-to-day optimizations that we're trying to make. Finally, I'll talk about the vision of what we want the performance team to look like in the future and how we want to continue growing our performance program at Pinterest. So first things first, what is Pinterest? I use it a lot for inspiration. It's a site where you can find inspiration for many different things. I use it for cooking, and as you can see, it's a pretty image-heavy site. So this obviously poses a lot of performance problems that are specific to Pinterest. Just to give you a little idea of scale, we have about 200 million global monthly active users, and we get about 1 million requests a little over 1 million requests per second. And we have about 400 engineers, so we've grown pretty fast, pretty quickly since we've started. And this obviously poses a lot of problems with scaling, not only just the site, but scaling the team. So we have a lot of engineers committing code to our code base. So some industry numbers, just everyone knows performance is important, but this wasn't enough to convince the team until we had something that that hit a little bit more close to home. So in 2016, we, as the web team at Pinterest, undertook this big migration to React from a framework that had been internal previously. And I have been on the web team for 3 years, so I've seen us go from that internal framework to React. And when we did so not just because of performance, but we also got these great performance gains that came along with moving to React. So we saw a 20% improvement in performance on one of our pages when we converted to React. And with that, we saw 10 to 20% engagement increases, which was really exciting. Similarly, we saw a 30% improvement when we converted Pinterest on-off pages, such as like sign up and login, to React. And with that, we saw large gains. Everyone was so excited about this. And so finally, we had this wide buy-in that performance was really important, and performance was really going to help us get these engagement gains. And so we started really thinking about performance at Pinterest. And previously, we'd had a couple of cross-functional performance initiatives, but no dedicated team. And so I'll talk a little bit about why the dedicated team really helped us push through our performance program. So when we got these numbers, everyone was really excited, right? Like, these are big numbers. But we actually had a lot of questions that started to come up. So because there had been no performance team, it only had been a couple of engineers here and there who were really passionate about performance, there wasn't the internal infrastructure to support these performance gains. So we had a lot of questions that would come up from engineers, like, are our performance metrics accurate? Like, no one's really on the day-to-day certifying this. Or how much faster are we really? Now that we've shipped a lot more code, maybe a few months has gone by, we didn't have a regression testing in place. We didn't have everything in place, and we couldn't really certify that we were continuing to be as fast as we were. We had no performance plan because it had just been a few engineers contributing time. And so there wasn't a great history of all the performance work we'd done at Pinterest. So it was hard for engineers to know what had worked, what had not worked. Finally, if there was a regression in performance, there wasn't anyone who was owning it. There was no ownership of that these performance problems. So we decided that we needed to focus on all of these things, a list of things that we wanted by the end of when we created our performance team. And we started with our dedicated performance team. So like I said, I'm on web. We also have an Android and iOS counterparts, and we are primarily client-focused teams to start with, and that's because we found that our biggest bottlenecks were in the clients. And now that we have the program, it's been running about 10 months now, we're actually starting to work on more server and hiring people for server work and back-end work. But I'm going to talk primarily about web. That's what I know. So one of the biggest things we had to work on was, when we started, was data confidence, and this idea that our metrics needed to be trusted and used by the rest of the company, right? So when I say performance, what exactly am I talking about? What are we measuring? What are we trying to optimize? Everyone seemed to have their own opinion on what metric we should go for. Should we go for time to interactive or visually complete, since we're such a visual site? But we actually go by this internal metric, or this specific metric called pinner wait time, and I'll show you what that is. So on this page, which is a close-up page, we actually measure the most important things on each surface. So in this case, it's the big image and the metadata about the image. So if this were a recipe, you can imagine it might have a lot of data about ingredients, et cetera. And we decided that these are the most important things on this surface that the user is going to engage with. So if you go back, we decided, the pins at the bottom, not as important. And so what PWT is a composite metric of how long it takes for each of these to load. And whichever loads slower, that's our performance timing. So and something that's really exciting about using our own internally specified metrics for performance that are different on each surface is that we can really start to tie these to engagement. We can change their definitions so that their definitions are tied to engagement. So we actually had an issue where we had a metric for one of our home feed pages, which had a grid of pins, where we were measuring something akin to visually complete. But when we did an optimization and this metric changed and we improved this metric, we saw we weren't actually getting the big engagement gains that we wanted. We were only seeing our metric go down, but not really getting any business value or engagement wins for the user from this metric. So what we actually did was change the metric definition. We changed it to be something more akin to time to interactive for our first page loads, so that we would start to see, and we make sure that we were getting engagement wins from our metrics. That way, our metrics weren't just vanity metrics, but we could really show the rest of the company that when a metric changed, it would affect engagement. And this was extremely important for getting buy-in from the rest of the company about the performance program, was to really tie all of our metrics to engagement wins and not just have them be vanity metrics. So the first thing we had to do was fight doubt about our program, right? We had to make sure people understood the value of performance. And so I'll talk about the steps that we use to build confidence in our performance program. The first was to set baselines. And so I talked about how we didn't have a framework that was validated. No one had really been on it. So this meant building all of the infrastructure, unit tests, et cetera, things that had been neglected in the past, to make sure that our performance metrics were correct and trusted by the rest of the company. And also so that they understood what exactly each surface was measuring, right? Because it was different from surface to surface because we're using PWT. So after our work, we made sure our metrics were validated, that we had our confidence tests, and that our graphs reflected real user experience, so that teams understood their metrics. The second thing we did was to tie performance metrics to business goals. So like that change from visually complete to time to interactive, we needed to make sure that performance could be a lever for each team to use to improve their engagement metrics, which is ultimately what our product engineers care and growth engineers, et cetera, care about. They care about the metrics on their surface that tie to user engagement. So before, teams were unsure what kinds of optimizations would tie into their team's goals. But we actually ran a set of impact experiments where we made slowdowns to different metrics, for example, time to first byte or time to interactive, and saw what was the exact impact on engagement. So because of this, we can now estimate what a change in each surface and performance might do for engagement. And so teams can budget time for projects that would change their performance for performance projects, and budget them based on the engagement wins. So this was really important in getting other people on board working on performance projects. Third is something I call our PR campaign. So we did some optimizations over the course of the 10 months, or the 6 months for our first half. And what I mean by our PR campaign is we made sure that everyone knew there was a performance team and that they could come to us for help on performance projects. And so we went to a bunch of all engineer events, and we kind of showed off our wins, showed off nice graphs with our optimizations, and let people know that we were here to help them improve their performance metrics too. And we actually saw a big increase in the number of engineers who were excited about performance and would come to us asking for help, asking to understand what they could do better on their surfaces. So now they knew where to come for help, and we started to see people getting excited about performance. The fourth was to fight regression. So this is probably the most crucial of the four. We actually got a shout out from our head of engineering to the whole company saying that one of the things we learned in this half where we started the performance team was that regression prevention could actually be more impactful than shipping optimizations, and that we should apply this learning to basically everything we do at Pinterest, right? That fighting regressions had really been the cause of why we were finally able to hold the line on performance that half. So we couldn't convince teams when there was a regression because our data we weren't really sure. We didn't have a way to check it before things made it to production. And teams didn't feel confident that their optimizations were protected if they made them, right? So we needed to make sure that they felt that if they made an optimization, it would be there, that improvement would be there a few months down the line. So when we made this regression framework, we started seeing a better trust in performance, people more willing to do optimizations because they knew they were protected, and more regressions caught. So now I'm going to talk about how we're doing this regression testing and what we created to make regression testing painless. So we created this in-house regression testing framework we call PerfWatch, which basically I'll walk through how it works. We're basically checking that commits that developers make aren't regressing performance at Pinterest. So our developers are continually merging codes to master. We have a lot of people working on the Pinterest site. So every several commits, we'd create a deployable production build. And we have a fleet of servers that are dedicated to performance testing. And so when one of these builds has been created, we deploy it to the server. So we check that one of the servers in our fleet is free, and we mark it as locked and build our Docker container. And we deploy that production build to the machine. So now we have the server running the specific version of Pinterest that we want to test. And we run all of the critical tests for all of our surfaces and all of our pages. So we have that for our most important surfaces that we care about at Pinterest, so the things that users are most likely to engage with. So we load the page and record how long the pinner wait time is for each of these. So for example, on the close-up page, we navigate to that page and see how long it takes for the image and the image details to render. And we do this several hundred times for each surface area to minimize change, and we run multiple tests in parallel to do this. So once the tests are complete, we calculate the 90th percentile in pin or wait time, which is the performance metric we're goaling against. And we stat these results to our real-time dashboards. So this is what a dashboard looks like. Here, close-up is pretty flat. There haven't been any regressions. So each point in the graph, it's kind of hard to see, is one test run. And here you can see that a little more clearly. Don't worry about the text, but when you hover over it, it shows you the build and the commits and other helpful data. So here's what it looks like when there's a regression. So we have alerts that go off when our tests start hitting above a certain threshold. So here we had an SEO page regression, and we're immediately alerted, and we can catch the regression before it makes it to production. So we're able to identify the commit, and we can notify the owner and let them know that they've regressed performance, and they can revert the commit. So because we don't run testing on every single commit, we have maybe a batch of commits. So we're not always sure what commit actually regressed performance. So we built something to address that as well. Sometimes it's pretty easy to eyeball which commit in the batch is the cause, but sometimes we don't know, and we're not familiar with the entire Pinterest code base to know the intricacies of every commit that might go in. So to deal with this problem, we built this tool we call Perf Detective. And so what it basically does is run a binary search with performance testing to identify the offending commit. So like a git bisect, we take our list of commits for every commit we want to test. We create a production build, kick off the perf watch framework on each of these, and test to see which commit is actually regressing performance. So we can just kick off this binary search. We don't have to do anything, and it'll let us know exactly what commit introduced the performance regression. And so this has been really, really helpful. It saves us a ton of time, and we can just relax when there's a regression. We don't have to spend developer time trying everything out, which was a real problem beforehand. And almost one of the causes that regressions really never got solved was because it took so much time. It took engineering time to fix every single regression. So with these two tools, we've been able to hold the line on regressions and hold the line on performance. And now that we had this in place, our optimizations could really matter. So alongside the building all of these tools and starting all this data confidence work, we also worked on optimizations. And so when we started the team, we were handed a pretty aggressive goal to reduce pin or wait time on our first page load of home feed. And so we had to create a strategy to hit this aggressive goal. So the first step we took, of course, was to analyze the current performance, brainstorm as many ideas for optimizations as we could, and figuring out what type of projects we'd want to work on. There were so many things when we started that we could work on and decide to do. We met with a ton of teams to see all of the ideas from across the stack and to bounce ideas off each other. So we had a list of potential projects, but we couldn't do all of them, right? We were only 3 people, and we want to do all of them eventually, but they might be different parts. We're not parts of the stack. We don't know. We don't have expertise in everything. So we needed to know which ones to prioritize. So we developed this approach called line of sight that we used to figure out how we're going to meet our goal. So basically what we did is log each project into a document where we're figuring out the amount of work and the payoff and noting any dependencies or blockers for each project. So this enabled us to narrow the list down to our best projects. So by doing this, we started prototyping everything. And so this meant either just doing a quick hack to experiment and see what kind of improvement, actual real user improvement we would get, or to make sure that we would actually hit our goal at the end. So we made sure to do this before starting work on really implementing these changes to the site so that we knew we weren't wasting our time. So this provided better estimates for how much we were going to get, and so we could really figure out what to prioritize. And we revealed a bunch of issues with some of the optimizations early on in the process, which really saved us a lot of time. So once we finalized these projects, we started experimenting, and we implemented these optimizations and put them into our experiment, or we created A/B experiments for them. So I'm going to show you a little bit about our experiments framework. We have performance integrated into that framework, so we can see what exactly are the engagement and performance changes with every experiment that we run. So this is an example of one of our experiment dashboards for one of our successful experiments. You can see we have home feed PWT. Blue means it's statistically significant, and this improved performance by about 14%. So, and this is one of the correlated engagement dashboards. So in this experiment, we saw engagement really increase. The metrics are blurred out, but we saw engagement really increase with just this one performance change. And this is the kind of data that we need to use to show the rest of the company the importance of performance, right? Just no one can argue with this exciting blue dashboard. So another thing that we wanted to do was figure out how exactly we're affecting different users. So in our experiment dashboard, we have exciting things like filtering by user state. So for example, for casual and new users, which mean users that don't use Pinterest all of the time, we found that performance had a larger impact for these users rather than our core users, who maybe show a higher intent to pin no matter what the performance is, but these new and casual users really were affected by performance. Another thing we use a lot is the country filter, and we see a lot of we see differences between countries, high latency countries, and we can really see what our improvements are to different segments of our population. So after this, there was a lot of rejoicing. We ended up hitting our goal of 14%. I actually exceeded it by 20%. And so we did that little PR campaign afterwards. And we were able to, because of this, we were able to show the rest of the company exactly how performance tied to engagement and shop this around as a potential a win that other teams could have as well. You know, we did it with 3 people, and while building the regression framework, while building all the other tools. So this was really exciting for us. Oops. So the last thing I'm going to talk about is our vision for the future. And so we've started working on this in the past few months. Now that we have an idea of what it takes to start that what it's taken to start that performance team. So we mostly have all of these things, or all of these things are starting to improve at Pinterest, and that's thanks to the dedicated performance team that we have on all clients. So we've started to think about the future and what we want our team to look like. Do we want it to be a team that does optimizations? Do we want it to be a team that focuses on tools? And what we've decided, we have these 5 pillars that we've decided to work on for the future. So the first is scalability. We've decided that we can't be the only people working on optimizations, right? We don't know every surface. We're not going to be the most efficient at optimizing every single surface. The product engineers are going to know their surfaces intimately and have better ideas on how to optimize them. So we want any product team to be able to take on an optimization target and do well. So we don't want to be the only people working on it. So we want teams to own their own surfaces when it comes to performance. So right now we're just the first line of defense, and we do all the monitoring and making sure that all of the metrics are sane, but we don't want to be the central control on this. We want products teams to really find performance to be one of their key metrics that they need to monitor. When we first started, we didn't have a knowledge base of performance. So now that we've been working on it for a little while, we want to share that with the rest of the team, with all the other teams, so that there's a central knowledge base for what performance at Pinterest looks like and how you might improve it. So this is something we don't want other engineers to waste time figuring out on their own when we've kind of collected all of this knowledge and data. Finally, we want to create the tools that developers can use for Pinterest-specific performance and make sure that they understand how to improve performance at Pinterest, and they can do it quickly and without issue. So we've worked a lot with developers to see what their pain points are and trying to solve them for if they were to take on performance projects. And we've piloted a set of tools with several product engineers to see what their reactions are and whether or not they're going to actually complete performance projects with our tooling. So finally, we want to continue to be the strategy, figuring out the strategy of performance at Pinterest. So figuring out what critical surface areas we might need to improve in the future, figuring out how the tooling and everything we want to do with performance at Pinterest. So to sum up, we've decided that we are not going to be the only performance team at Pinterest. We want all of the engineers to feel like performance engineers. So if we distribute the work, we'll get gains on every surface, and we'll hope that performance can be a priority for everyone. That's all I have, so thank you, everyone. You can tweet me at SarahDDubs, or just come find me, then I'll be here to talk to anyone. So thanks.